Who's a programmer? Sky is here. Who's a designer? Good. You can raise your hand more than once. Who's an artist?
Everyone is an artist.
Who's a statistician? Who's a doctor? Is there a doctor? Who's a physician? Sorry. See, I speak with a French accent. Yeah, exactly, physician. Very good. Anything I didn't mention? Researcher? Yeah, he's a researcher. Oh, there's a lot of researchers. And there's a lot of people who raise their hands several times. Very good. I'm sorry? Urban planners? Oh, coincidence. Absolutely.
Journalists.
Very good. Well, since we know you a little now, let me introduce you the team of Visualisation Montréal. In the corner here we have, well, let's start with in the back at the camera we have Santiago Salcido from Radio-Canada, from BBC here in Montreal. There at the table we have Jessica Renaud from Videotron, also an organizer. And here we have Christophe Villot, the D3 legend. Working for MAPD. And we have a few former organizers as well. I see Audrey here, who has designed our logo. She's creative director at Function. Et je vois Nicolas aussi, au fond, Nicolas Coustel, un autre membre fondateur. Est-ce qu'il y en a un que j'ai pas vu qui était dans le comité aussi? Non. Alors, the meetup was created almost 4 years ago by now. We have over 15,000 members. It's the 10th time that we meet, and we have a Twitter account that we like very much. It is now at 351 since I wrote this. And we have a hashtag that's there on this. And we really encourage you to tweet and to use the hashtag. We like that a lot. It's a return for the free pizza. This is the kind of people that we had in the past amongst our speakers. I'm sure that you're recognizing a few names there. Some of them are local, but also we had visitors from outside, like we're doing today. So it's been a good ride so far. And let's go back to the Twitter account, because what you're going to find on it is stuff like data about Montreal, graphs about Montreal, meetups that can be relevant, and even job offers, actually. So we recommend, this is, I already named them. And our projects, this is our second for this 2017-2018 year, and at the end of the meetup, we're ready to announce the next one in May. And we have a video, a YouTube channel, if you're interested to see them again, or recommend them to your friends and colleagues, and we blog also about what we do. And today we're here for the 10th one, called Avant-Garde. Let me first thank OVH that is hosting us today. Very nice. We love the big screen, by the way. I don't know what the OVH representative is, but thank you for the big screen. And we'd like also to thank our other sponsor, which is MAPD. They're the ones who are feeding you today. And at the end of the talk, we're going to speak a bit more about that. At the end of the talk, there's going to be two more things. First, you're going to be allowed to make announcements. So you just raise your hand, and so you can also be nervous for the next hour and a half. You think I'm going to speak in front of that group. That's good. We'll give you that opportunity. And at the after, when we're done, we're going to go just down the street here to have drinks if you're interested, to continue the conversation. We're going to give you all the details at the very end. And I think that covers it for the introduction. We're going to get started now with our first speaker, Jessica Holman, from the University of Washington. Her first job was to develop a visualization. We've asked all of our speakers to tell us what was their first job in database, because many of us are wondering how to get into this field, and also what is their dream last job in database. And Jessica is at the University of Washington, And her first job was to develop a visualization interface for a marketing company, and she says that she would cringe if she saw it today, but don't we all? We saw it first thing. So, and her last one, I love that very much, she would be head of statistical communications at the New York Times. This is also what we're all, right? No, okay. Very good, so just give us a minute, it's finished.
Okay, hi everybody, thanks for having me.
I forgot something.
Sure.
You can say good. You can say hi.
So yeah, hi. I can talk while you're doing this?
Yes.
Yeah, I'm an assistant professor at the University of Washington. I do data viz. I do a lot with communicating uncertainty, also kind of storytelling and visualization, so sort of AI plus visualization plus HCI, human-computer interaction. Today I was going to talk about some work I've been doing on trying to basically help people better understand measurements using concrete re-expression strategies, and we're trying to automate this. So visualizations help people understand numbers, obviously, by giving them a nice representation. But another way to help people understand numbers is to give them mental imagery, and sometimes this is actually more important or an important first step before you visualize data. So for example, we often see physical measurements like length, height, volume, weight, etc. in news articles. And often readers struggle to understand how much these quantities actually refer to. So there are various reasons why they're hard to understand. So you might not know the unit well. So how much is a gallon perhaps is not familiar. You might not know the magnitude well. 34 million gallons is a lot. It's hard to grasp. And even the measure itself, like volume, might be something that you don't have to reason about in everyday life. So people struggle with understanding measurements. So if I were to ask you how much is 1,000 gallons, what would you think of? I'm guessing you would try to start thinking about objects that are kind of in the ballpark of what you think 1,000 gallons is. And people who study in psychology how people mentally represent measurements find that they're often thinking about a scale of measurement sort of anchored by familiar objects, so things that they're familiar with the scale of. Journalists and designers, I think, kind of know this or intuit it. And so often you'll see them when they're including measurements in news articles using these concrete re-expression strategies where they're kind of re-expressing a measurement in terms of familiar objects. So 34 gallons is about 1.5 times the volume of a wash tub, or 1,100 pounds is about 5 times the weight of the gas range in your kitchen. And so this seems very simple and concrete and direct, but it's actually hard to construct these and really get them right. And that's because the comparative object is really important. You have to kind of get the right object. It's not clear what makes for the right object. And so they go through this manual process where they have to think about objects in the world and their properties, find measurement data on the web, which may or may not be accurate, convert the multiplicative factor, so figure out, is that easy to understand? Can I tell someone that it's 20 gas ranges, or is that hard for them to grasp? And then find a way to present it to the reader. And so our work is really looking at whether we could support automatic generation of these measurement analogies and then visualize them and make them available to people. And we're going to do that by making use of publicly available object measurement data and focusing first on physical measurements like weight, height, length, and volume, because people encounter those a lot just in articles, et cetera. So we're going to build a database of measurements for objects that we think are familiar to people and then construct automated algorithms for those. And so to build the database, we have this kind of 3-stage process where first we're going to think about objects that have criteria that we think are good for re-expressing measurements. Then we'll obtain instances of those objects from various online sources, and then we'll make sure that the objects that we got instances for are in fact represented by those instances. So briefly, let's walk you through this. So our first step really was trying to think about, well, what criteria should an object have to be sort of effective as a re-expression? And so one thing that's obvious is that if you're going to re-express physical measurements, you want concrete objects. They should have mass. They should take up space. You also want things, though, that are countable. So I could tell you 90 grams is equal to the weight of sand, but that's not very helpful because sand is ambiguous in its quantity. You also want them to be familiar. So you want objects that people not only recognize, like a hippo, but that they actually interact with in daily life, so they have a sense of the scale. And finally, you want objects that have low variance in the measure. So I could tell you 35 pounds is equal to the weight of a dog, but you don't know if I mean a big dog or a small dog. There's a lot of variance, and so we want things that don't vary that much. So once we had these criteria, we were able to go to semantic databases, and namely WordNet, which is basically a graph of concepts, where the concepts are called synsets. They have a definition. A lot of them are objects, and you can sort of reason about the attributes that these objects have based on where they are in this WordNet graph. And so basically we looked at sort of the high-level nodes in this WordNet graph. We found that artifacts are defined as man-made objects that can be taken as a whole, and this sort of corresponds nicely with concrete countable objects. They have a clear quantity, and they're obviously concrete things. We also wanted things that were familiar, and so by using WordNet, we were able to also use a measure from a related database called ImageNet, which is basically an image-based version of WordNet that includes a measure of the popularity of these various objects in web corpora. So online, how often are they mentioned? And so we use that to kind of get rid of some unfamiliar objects, and so we're left with about 2,000 objects, or synsets as they're called. And so then what we can do is go out and gather measurement data. So we created kind of a pipeline to automatically extract measurement data from a few sources. One was Amazon, the product database, where they have a whole bunch of consumer goods, mostly things that fit in a box, but still a wide range of objects. And then we also used Wikipedia, which has a lot of objects across different scales, where you can get measurement data in these little tables called info boxes in the articles. And so we queried basically with these adjective phrases for each synset or object representation. We used different strategies for each of these two sources, but basically we got a lot of instances of these objects where we have measurements for these things. And so that leaves us with about 25,000 instances of objects, and we are now down to about 1,300 object types or synsets. But as you might expect, we got a lot of false positives, so cases where it's not quite the object we intended. So if I put in a search on lighthouse in Amazon, it's going to give me things like cookie cutters, and so we had to filter some of that out. And so we have a last step, which is kind of filtering this database. We're using crowdsourcing, Mechanical Turk, which is a crowdsourcing platform, to do that. So we end up creating this database that has about 13,500 instances of about 1,200 objects. We've created web interfaces and an API for developers who want to just use this data directly. But again, our goal was to create automated sort of analogy or re-expression algorithms that we could then use on demand with visualizations of the results. And so we took this database and we started thinking about these re-expression strategies and how we could potentially automate those. So one that's really common is reunitization. And all three of these examples show reunitizations of 1,000 gallons, where you're basically re-expressing 1,000 gallons as a multiple of some more familiar object. And so we have all these objects in our database. We can try to then reason about, or we could create a reunitization for any of them, but then we have to sort of think about which is the best reunitization for this input. And so our goal is really to rank them. And so the way that we do that is basically defining kind of a function or an equation that's going to basically rank all of the objects in our database according to various criteria that we think are important for these re-expressions. So familiarity of the object is important. Variance in the object should be low, that's important. And then how easy to understand the multiplier is also important. So here in the top example, the multiplier is 8.9. Is that really an understandable number versus 2.4, et cetera? Just briefly kind of how we define these scores. You can think of each of these terms in the equation as a score for how good the object is on those in those ways. And so to get familiarity, we basically know from research in psychology that what is familiar depends on the specific magnitude. So you think of different objects depending on what measurement I give you. So we had a task that we had crowd workers do where we gave them a sample measurement and showed them a grid of objects and said what objects are familiar to re-express this measurement. So we basically get these kind of ranked objects according to the results of this task. We then looked at the actual distributions of measurement data and figured out which objects have low variance in the measure because we want to prioritize those. So these are two similar objects, an oven and a gas range, but gas ranges have less variance. Oven might include some really small things. And then finally, we're trying to score the different reunionizations based on how easy this multiplier is to understand. And we can look at psychology research that says that people have like a really good sort of precise notion of numbers 1 through 3. And then 4 through 10 are not too bad. But then as we move away from 1 or get higher than 10, our mental representation of numbers gets imprecise. We're just not very good. And so we can do all this, and we can automatically, create these reunitizations. We get for 1,000 gallons 2.4 times the volume of a hot tub, et cetera. And so these use familiar objects. They seem okay, and we've evaluated them in multiple ways. But like I said, we were really excited kind of more about how we could apply this type of thing sort of in the world, and particularly in journalism where you'll see news articles. So we created these different interactive reader applications that will apply these re-expressions on demand and then express them using sort of simple visualizations. So here, someone clicks on this, they get the top 5 reunitizations from our algorithm. But we're creating these little bar charts. Basically, we're taking images of this object from ImageNet and setting a constant width so that you get these little bar chart type things that people can quickly scan and compare. We had another strategy that's sort of represented more as a number line, where we're going to look and take the top objects from our database using similar equations, but the ones that are sort of near the measurement that the person's clicked on. So you get a sense of objects that have measurements close to this. And then finally, we had a strategy where our visualization is not so sophisticated, but it's a proportional analogy where you click on multiple measurements and you get a pair of measurements that are that have the same ratio between their measurements. So, here we could probably do fancier visualizations. I think it'd be fun to sort of design something to show that ratio better. So that's kind of what I have to share today. We have a bunch of stuff online, data. We have demos. And I also wanted to mention, if you like this type of visualization of measurement analogies, we have a browser plugin for a different project where we're making personalized maps for spatial measurements like distances and areas. So check that out if you're interested. Thanks.
Merci beaucoup, Jessica. On prend 2 minutes par conférencier si vous avez des questions à poser. On en a une ici déjà.
So what I wonder is there any research on whether an integer number is easier to understand than a fraction? Because I wondered why you didn't just round to an integer, because lots of these measurements have an uncertainty, like not every is this exactly the same. So might as well just round.
So we do round. Actually, we have a rounding strategy. We sort of cap the rounding once we've lost more than like 5% precision with the actual measurement. So I think it's interesting to think about what people do with numbers. I think probably when you show them 2.4, they do round. Maybe they round to 2.5. But we figured it's better to let them round in their head than sort of round and lose precision in that way. There was actually research at the conference presented on how people do understand fractions like 0.5 or and maybe a quarter, et cetera. And so we looked at psychology research and we couldn't find anything reliable about like how people understand fractions or which fractions do people understand. So we didn't incorporate it, but I think there's now more recent research that we could use. But yeah, I think it's complicated to know kind of what people, I don't think people actually care about the decimal points all that much, but we show them because we don't want to like get rid of information. So thanks.
Yes, I assume you don't round when you're treating astronomical data or atomic emission data, because that is known very precisely. You make constraints on that?
So in this case, we don't have any astronomical stuff. We have, the biggest objects we have in our database are coming from Wikipedia, and so we have things like big bridges or huge buildings. I think we have like space stations, but we don't have anything, astronomical. And there, we're keeping track of significant digits in our database. Like, so we're getting the measurements, and then we're starting with like whatever a number of significant digits we have just from the data we collected itself. But
on va prendre une dernière question, je pense que Nicolas, oui.
Did you look at the sort of affinity between the reunit, I guess, the new unit and the original thing? Like 1,000 gallons seems to me it would be like a 10 by 10 by 10 cube of gallons of milk, like sort of liquid to liquid, or like.
We didn't have anything that would specifically say like liquid to liquid, but I think it comes out actually in this task that we had people do where we showed them a measurement and we said, what's a familiar object? And so when you show them like something like 100 gallons, they're more likely, I think, to say that the objects that are familiar are things that I think of as having volume. And so I think it comes through in that way. But yeah, I think you do want to kind of match sometimes like you want things that hold water or whatever, or milk, et cetera. And so we wouldn't have one that's like 1,000 gallons of milk because we're trying to cap the multiplier, or we're trying to minimize the multiplier, keep it in this range really. So, but yeah, I think there's lots of ways you could expand this to kind of be more sophisticated. I think it's hard to know exactly how people deal with measurements, but yeah, this was a kind of first stage attempt.
Thank you so much.
Thank you.
Regarde le rythme assez rapide. Aujourd'hui, je n'ai pas mentionné beaucoup au début, mais on est vraiment chanceux d'avoir ces 8 personnes-là qui sont venues nous parler. C'est très rare qu'on a autant de gens qui sont à la fine pointe de la visualisation comme ça, de passage à Montréal. On est vraiment contents que autant d'entre eux aient choisi de venir aujourd'hui avec nous présenter. Et l'autre chose aussi, c'est que vous avez beaucoup de questions. Ils sont encore dans la pièce, il n'est pas trop tard pour les attraper. Et l'autre chose qui est spéciale à propos de la visualisation d'aujourd'hui, du meet-up d'aujourd'hui, c'est que c'est tout basé sur des articles qui ont été écrits. Donc, vous allez sur la page du meet-up, vous sélectionnez le titre de la présentation, vous le mettez dans Google et vous allez avoir le paper au complet, si vous voulez lire le détail de comment les calculs de chacun sont faits. So our next speaker, Arjun Srinivasan.
That's as good as I can do.
As you do, okay. Very good. So his first job in data visualization was to develop a sports dashboard for a challenge organized by SAP in India. And his last job, he hopes, will be in research in an industry lab or with a few teaching gigs on the side. So very good, Arjun. It's yours.
Right. Good evening, everyone. I'm Arjun Srinivasan. I'm a second-year PhD student at Georgia Tech, and this is work done in collaboration with Matthew Bremer, who's back there, Bongxing Li, and Stephen Drucker at Microsoft Research. Let's set up the context a little bit with an example. Can you all raise your hands if you've seen a dashboard like this one that shows sales or some sort of values for a given year? All right, that's almost 90% or 100% of the room. So I'm sure many of us have seen these kind of dashboards. And for instance, this one over here shows carbon dioxide production levels for a given year, in this case 2015. Now let's just focus on this chart that shows us monthly values. So looking at this, we can observe a bunch of things about the data. So we can see things like July and December had the lowest values. There was a bit of a decline between January and February. Other months had some pretty high values and so on. But one problem with this is that we don't know what these values mean. Like, is there a context to this? For instance, we know that July and December had low values, but is this something specific to 2015 or was this something consistent across the years? Alternatively, if I toggle between 2014 and 2015 values, you can see that July has risen by a huge amount, whereas some other months like September and October have dropped by a huge amount. Yep, I said. Oh, no, the other way around. The July month has dropped and September and October have risen by huge amounts. So as illustrated by this example, unfortunately, most dashboards today or many visualizations in dashboards today don't provide such context that might be critical when you're looking at a visualization. So as part of our work, we explored various visualization designs that can help highlight such differences in the context of dashboards. We specifically looked at bar charts because they're probably the most common way to show data or commonly used visualizations in dashboards today. Now, as is often done in research, before we sort of set out designing solutions to validate how important the problem was, we conducted some interviews with dashboard experts in the form of product managers of Microsoft Power BI, and we also looked at publicly created dashboards in both Power BI and Tableau. We observed three main variants of comparative visualizations these dashboards have to offer today. So the first ones were cases like these, where the series that were being compared were juxtaposed or put side by side. So on the left, you have values for 2014, followed by on the right, you have values for 2015. A related design was one where this juxtaposition or grouping was based on categories, and this was shown using a more classic grouped bar chart. There's obviously some good things about these designs, right? So, for example, they show the original or the raw values, so you can still look at a dashboard and get the context of what the current values are, which is good because you want that you're just glancing at a dashboard, you get the right values, and you can move forward if that's all your goal is. Another good thing is that they preserve the space on the dashboard, so that chart would take the same amount, the bars would just compress, and they would still remain a bar chart, so it's not like you have to learn a new visualization just to understand what the change is. But these visualizations do have some issues when it comes to comparison in particular. So they can be misleading when the data categories are varying. For instance, in this chart, if one of the products was missing a value in a previous year or just did not exist, this chart would show it as having a value of 0, which is false. And you can see this happen in multiple examples. So product 2, 6, 7, and 13, they look like they just have a value of 0 for the previous year, but in fact these products just did not exist. So instead of saying that it was a missing value or did not exist, it shows it as having a value of 0. Secondly, unless you sort of have numeric labels like you have in the example on the top, it can get pretty difficult to understand or measure what the difference is, because you have to first perceive what the value is and then do the calculation mentally. Another type of visualization that we saw in dashboards which were currently used were these sort of charts that directly showed the computed difference. So in this case, the chart is showing changes in policy growth values between 2 years as a percentage. These designs are great when it comes to highlighting or allowing users to measure the differences directly, but they have some other limitations. So since they don't show the raw or actual values, they typically need to be used with other visualizations that actually show the raw values, and this leads to wastage of space on the dashboard. Furthermore, for some things like the earlier example of dynamic data categories where they come and go between years, this kind of a chart is never going to be able to tell you what categories are new to this year or were specific to the previous year. Even with these kind of limitations, we surprisingly found these to be one of the most common ways to show data on dashboards today. Given some of these limitations with these existing designs individually, we sort of wanted to see, is there a design space that combines the good things about all of these and sort of still shows all the good things that this one can do and all the good things that that chart can do, and come up with a new design space. So given our findings from these interviews and the surveys of dashboards that we conducted, we set out to explore other possible design variations. We implemented an interactive interface that allowed us to configure and compare different charts that facilitated comparison. So we varied properties like color, sorting order, and mark type, and different design strategies. Now, since this essentially rendered a bunch of bar charts, we called it the bartender. And there's some more bar jokes coming on, so if you want to grab some beer, you should. In terms of the designs that we considered, we looked at some what we call juxtaposition-based designs. So these involve side-by-side. So on the top you have a series 1, series 2. On this one you sort of have series combined into a single chart. We also looked at some explicit encoding or derived value-based designs. So things which directly compute the differences and visualize that. And some superimposition-based designs that sort of take the values for one series and put it on top of another. In addition to looking at variations sort of among a single design category, we also looked at charts that combine these strategies. So for example, this one over here combines juxtaposition, explicit encoding, and superimposition, and overlays these different lines which are shown in purple on top of this grouped bar chart. So in this case, the active series or for the year 2016 is shown as a blue bar, whereas the previous year or 2015 is shown as orange, and the purple lines represent what the difference is between the two. If you notice, there's a slight offset, and that's to show that it's sort of a derived value as opposed to the raw series value itself. Similarly, this other example combines explicit encoding and superimposition. You can see the active values as shown as blue bars, and the differences compared to the previous year shown as purple lines. Now, once the bartender served us over 20 design alternatives, we distilled or picked out 4 of these to study them further. And those jokes were not written by me, so please. 2 of these were again baseline visualizations that we saw earlier. So you have the grouped bar chart and a variation of what we saw in the difference chart. And this was done, as I'll just talk about, just to maintain consistency in terms of what the experiment was. And the other 2 designs that we compared these 2 against were superimposition or overlay based alternatives of these, which showed both the raw values and the differences. So to test if these charts actually were usable and people preferred them and they could potentially even be used to substitute these existing designs, we then conducted a user study. We conducted an online experiment with 74 participants testing their performance for these 4 visualizations across 6 tasks and 2 data conditions. I'm not going to get into too much of detail about this, but just to give a sense of what participants were looking at, here's an example of a task. So in this case, the participant is shown monthly values for 2002 and 2003 and is asked to enter the change in value between the 2 years for the month of June. So they look at the chart, they just go ahead and they enter in a value. We did this for each visualization type. Participants were provided with an introduction to the visualization itself, some example data sets, and they were allowed to test out a few tasks so that they can get familiarized with the experimental setup and the visualization. And then they performed a set of training or testing trials. And for each trial, we recorded the amount of time it takes for them to compute the answer, how far off or how correct they were, And we also recorded subjective preferences in which they could tell us which chart they liked most or least and why. In terms of the results, at a high level, we found that when it came to tasks that involved finding the extreme values in the active series or tasks involving sort of series-specific categories, these hybrid designs, or the ones on the right, performed comparably to this baseline visualization which is used in dashboards today. But specifically when it came to difference-based tasks, these designs performed much better than this one. These hybrid designs also performed comparably when it came to these difference-based tasks against that other baseline visualization, which is suited specifically for that category of tasks. In terms of subjective preferences, we found that most people preferred this visualization, and it was about 85% of the people saying that this is the visualization they like the most. And on the other hand, the difference chart was the one that people said that they liked the least. And this was surprising, given that this was one of the most common designs that we saw used in dashboards today. So such findings, along with the fact that the combined hybrid visualizations sort of allow more tasks, highlight potential value in exploring these designs further. To just give a flavor of what kind of future work exists in the space, I'm going to show a quick example of what can be done with these hybrid sort of designs. So one potential application is in narrative visualizations. So these visualizations typically use animation as a technique to sort of reveal changes over time. But depending on how much you're animating, it can get pretty difficult to keep track of what's happening. So these difference overlays can kind of be used to smoothly reveal what the change is. And this can in turn help people to sort of keep track of the changes and better follow the narrative. To summarize, we found that people really want to look at differences on data and dashboards, and they often want to do so without explicitly interacting with the visualization or the dashboard itself. And we looked at some designs which can allow people to perform such visual comparison, and we found that these can exhibit not only comparable performance in terms of tasks, but also they were subjectively preferred. On that note, I hear the beeper. I thank you all for your time, and I'm now ready to take your questions.
On a des questions pour Arjun? Je suis sûr que tout le monde ici fait des bar charts. Oui?
Yeah, okay, so I'm trying to figure out, so you have the goal, right? Your goal here is to figure out differences, right?
Yes, one of them.
Have you kind of researched or looked at trying to find by exceptions and trying to be more about highlighting the exceptions? Meaning, right, the person wants to see, compared to last year, which one has big difference, right? Because you don't want to see necessarily what's been the same, right? You're trying to highlight what is really a difference. What is so that's the actual goal of the user, right?
Great.
So I try to understand if you explored exceptions more based.
So unfortunately, I was just seeing if I had some of the backup slides. I don't have it over here. But we did look at that in the initial designs that we were considering. So in this interface, there are some options which, let me see if I can pause this at some point. Yeah, all right. Yeah, okay. So we did have some options over here which sort of allowed us to highlight series that were, or values that were new to a specific series. So for instance, if there are 3 categories or 2 products that are only specific to the year that you're looking at right now. So we would sort of put marks on them or highlight them specifically to show that these are new categories. So you might want to focus on these further. But again, that's formally studying that is a different study in itself, and that was beyond the scope of what we were doing now. But yes, we did consider that, and I think that also comes down to what is sort of the context in which all of this is being used. So if you're looking at, I don't know, sales or something like that, and you care about new products more than old ones, then maybe we want to put those in bold or show those kind of extra annotations. But we also have to be careful because at the end of the day, like we found initially while speaking to both the product managers and sort of users, that at the end of the day, you want to make sure that you can just look at values off a dashboard. So dashboards are also typically used sort of in ambient displays. So you don't want it to be like, oh, I take 5 minutes to just understand what's going on. You also want to be able to take a look and get the data and then just leave. So we want to make sure we strike a balance between that.
Est-ce qu'on a une dernière question pour Arjun? Tout le monde va aller lire ce paper.
Voici, I guess.
Yeah, et en anglais, de la part de Fanny, dont le premier emploi a été chargé de recherche à NRIA en France, l'Institut de recherche, et son dernier emploi, ce serait d'être professeur à l'Université de Toronto. Alors on lui souhaite bonne chance. parce que Fanny est déjà professeure à l'Université de Toronto. Et le deuxième, c'est Nathalie Riche, Nathalie Henry Riche, qui nous vient de Microsoft aussi, et qui, son premier emploi était à Microsoft Research. Et son dernier emploi, on lui souhaite de réaliser son rêve, c'est
d'y rester.
Microsoft Research.
Don't get fired.
Donc voilà, people who have arrived here, who have made it to their dreams, jobs, and no more, it's you.
Il y a un petit problème de...
Ouais, c'est un petit peu gris.
Il y a une partie, guys.
Non, c'est voulu.
Ah, c'est voulu.
Good evening, everyone.
Well, you could explain what
Bonsoir tout le monde.
That's going to be the presentation style.
Parce que c'est la loi au Canada, il faut tout traduire en français.
But I can do the English with the French accent.
Je vais faire le français avec l'accent français. Les langues.
I'm sorry. It's just
Okay, it's going to be like this.
Maybe
So-
it's just the cover.
Yeah, how interesting. Anyway, so we're going to talk today about how we can help people turn data into art.
On va parler ce soir donc de comment on peut tourner, représenter des données de façon artistique. Ça va être fun. Vas-y.
Je vais le mettre là, entre nous deux. All right, so one example, probably lots of you know about Dear Data, this project. Do you?
Combien d'entre vous connaissent Dear Data?
Okay, so that's a beautiful project. You can actually see it at the MoMA, and that's two designers who collected personal data and turned it into beautiful visualization that they hand wrote on postcard and they sent to each other. And you could see it on the book.
Donc c'est un projet où deux artistes ont décidé de collecter des données personnelles dans leur vie de tous les jours et puis s'envoyer mutuellement des cartes postales en représentant ces données de manière artistique. Et on peut retrouver toutes ces visualisations dans leur bouquin, leur livre. Stop laughing.
We like this project because finally we can use our entire brain. The part that's the analytical one, and then the part that's the more creative and expressive one.
On aime beaucoup ce projet parce que éventuellement maintenant on peut utiliser les deux parties de notre cerveau. Parce qu'on est des data scientists, on aime bien faire des données du côté du cerveau côté droit, mais beaucoup d'entre nous, on aime bien aussi dessiner, etc. Et donc finalement, on peut utiliser cette partie du cerveau aussi.
But most importantly, our dream ideal goal is to help everyone use their entire brain.
Et notre objectif, c'est que tout le monde puisse bénéficier de cette opportunité d'utiliser toute l'entièreté du cerveau. J'invente des mots, hein, mais c'est pas facile.
We didn't rehearse, so that's fun. Okay, so to do this, empower anyone to create expressive and whimsical visualization from data. We are taking the opportunity of using gorgeous devices that have pen-enabled input.
Donc on a accès à beaucoup de technologies qui sont très puissantes pour pouvoir dessiner facilement et donc on va se servir de toutes ces technologies pour créer des visualisations qui sont expressives et agréables, fun à créer. Voilà.
Voilà. So, because it becomes really boring, we're just going to show you what we've been doing. So let's fast forward a little bit. And imagine you're coming back in about 100 days for Dogfest.
Donc comme on va vous présenter ça avec un exemple, on va se projeter dans le futur et comme beaucoup d'entre vous vont probablement assister à ce festival sur les chiens à Montréal, ici même. C'est réel.
122 days, or maybe 121 now.
Dans 122 jours ou peut-être 121.
All right, so let's imagine I've been there, I love dogs, and I'm a data nerd. So I've decided to collect data about all the dogs I'm seeing.
Donc on va imaginer que Nathalie est allée à ce festival et c'est une data nerd et elle adore les chiens et donc elle a collecté toutes les infos sur les chiens qu'elle a vus à ce festival.
And since I want to show it to my friend Fanny, who cannot remember anything, I decided to put it in a spreadsheet.
Et comme elle veut me montrer donc toutes ces fabuleuses données sur les chiens, elle va enregistrer tout ça dans une base de données ou une spreadsheet. Et donc me montrer ça avec Dear Data, avec Data Inc. Pardon.
Data Inc.
Data Inc.
So I'm going to load my spreadsheet and I'm going to start draw nice visualization. So here I'm going to try to draw something that could represent my data, so like maybe a dog. And if I connect my data to that particular visual representation, every row of my spreadsheet, which represents a dog I've seen, is going to be represented by a little icon or glyph in the interface there.
Donc, ce que Nathalie vient d'expliquer, elle va commencer par dessiner chaque point d'élément du jeu de données, donc un chien, et donc elle dessine une petite tête de chien, et comme elle va vouloir représenter toutes les données avec ça, elle spécifie au système que chaque petite tête devrait représenter un point de données, et donc les chiens sont dupliqués, chaque chien représente une ligne dans la spreadsheet.
All right, so if I touch any of those little representations, I have access to all of the data that is in my spreadsheet, such as the color of the dog or the length of its fur.
Donc si on clique sur une des glyphes, on a accès à toutes les informations sur les chiens, comme la couleur du poil ou la taille du chien et qui promenait le chien.
So I can just select the little glyph, and then I actually also have access of all of the different visual variables that I can use to encode additional data, such as the color here, that I'm just manipulating by using my pen and touch.
Donc on peut aussi accéder aux propriétés graphiques de chacune des glyphes parce que c'est un outil de dessin. Et donc on clique sur la glyphe, on a accès à la couleur pour remplir la forme. Et donc on peut changer, comme dans un outil de dessin traditionnel, la couleur de remplissage de chacune des formes.
But what's interesting really is to try to tie it to one particular data attribute, such as the actual color of the dog. So I do this by binding the visual property to the actual data attribute. And now, if you notice, when I change the color of the dog that is black, all of the other black dogs become black, and so on.
Et donc, ce qui est intéressant, c'est plutôt comme on a des données ici, c'est de rattacher les propriétés graphiques de chacune des glyphes aux propriétés des points de données qu'on est en train de représenter. Donc, ici, on va transformer tous les chiens qui sont marrons, on va les rendre marrons, et vous voyez que ça se propage sur tous les chiens noirs, etc. Donc, c'est bon.
But that could be actually quite tedious. So we can also act onto a little panel on the top that's called the legend, and we could just interact with every single type of value of the attribute and set a color mapping.
Donc comme ça peut être assez pénible de faire ça manuellement, trouver toutes les propriétés différentes de chaque chien, on peut aller directement travailler dans la partie en haut ici à gauche qui est la légende et donc changer chaque valeur individuellement pour colorier tous les chiens avec la couleur qui va bien.
So in addition to the actual visual representation or the glyph, we can also manipulate the layout, such as grouping the dog by different type of properties. Here I'm grouping them by the length of their fur.
En plus de rattacher les propriétés visuelles de chacune des glyphes, on peut aussi travailler avec le layout pour représenter les données d'une façon particulière. Et ici, on utilise donc certaines dimensions pour grouper les chiens par différentes catégories.
Are you impressed? I can manipulate each of my group, and here I'm going to create a very simple bar chart-like representation. And you see that I could just touch one of the group and then draw the actual layout I want them to have. So simple use of my pen to say I want them aligned along this particular stroke. And I can quickly erase and draw another one if it's not to my liking.
Donc, ce qui se passe ici, on a les 3 collections de chiens qui représentent différentes longueurs de poils. Et donc, on peut travailler sur chacune des collections et proposer un layout en dessinant tout simplement comment on voudrait que les chiens soient répartis dans l'espace en utilisant le crayon directement sur le canevas.
All right, so we did probably a very bad job at explaining what this app is doing, but funny, I hope.
On n'a probablement pas eu la meilleure performance pour vous présenter ce travail. On espère que demain, donc le papier va être présenté demain à la conférence CAI, pour ceux qui sont à la conférence. Mais tous les détails sont dans l'article et on a une page web dont le lien n'a pas été...
Okay, so now I'm doing it. She took the lead. So yeah, so come tomorrow if you can sneak into the conference, Palais des Congrès, you know, no one really checked the badges anyway. We're going to be in 517B. Hi June, who's the lead researcher on this, and the grad student who basically did all of that. Will do a much better presentation, I'm hoping. And it's tomorrow, 9 a.m., 517B. Just shameless plug. For all the people that are interested in communicating with data and in communicating with data in an exciting way.
Donc Nathalie, t'exagères, fait de la publicité pour son livre qui promeut la communication des données dans d'autres styles plus basés storytelling. Mais le bouquin est très bien, un chapitre d'ailleurs où je suis aussi.
Fanny did the content and I just edited the outside. And actually Benjamin drew the cover, so thank you Benjamin. But this book contains basically the thought of many researchers, like about 40 of the leading researchers in DataVis, who got stuck into a German place and to discuss about that topic, and then forced by me and other co-authors, co-editor to actually write something. And you can just buy it on Amazon and it's fine.
Voilà, donc ils nous ont incarcérés dans un château pendant quelques jours. Et ils nous ont fait travailler très dur, mais on a eu beaucoup de très bonnes discussions. Et donc le fruit de ce travail acharné avec plusieurs chercheurs dans le domaine a donné ce bouquin. J'encourage tout le monde à le lire, non pas parce qu'on est dedans, mais parce que c'est plein de bonnes choses pour utiliser tout le cerveau.
Merci.
Merci. Ah, thank you.
Thank you very much. La présentation était très funny. Et c'est vraiment un bon exemple, je pense, aujourd'hui on voit l'avant-garde, on voit le futur de la visualisation, des outils qui pensent très différemment de ce qu'on utilise aujourd'hui. Donc on va voir dans 5, 6, 10 ans si ce genre de modèle-là s'est répandu. Est-ce que vous avez une ou deux questions? Oui, une question.
Il me semble que sometimes you allow the user to actually sort of make a make visualizations that are not particularly good at comparing stuff. So in this example with the bar chart, you have one that had much fewer items, but you drew the bar really high, whereas if you want to compare it to the others, it will be wrong, right? If you look at the length anyway. So did you think about putting in some sort of constraint to help people not make errors?
N'importe.
Okay, I can answer in English. You could.
I will do my own answer in French.
Okay. So in this first iteration, we focus on really enabling people to try and iterate and look into encodings, and the focus really was, how can you enable someone to really almost draw and then try things and realize, oh, it doesn't look good, and then do it again. And of course, when you do this, when you offer someone a super powerful tool, well, someone can just use it in a really kind of bad way in some ways, right? So that's kind of the trade-off of making it simple and empowering anyone. Well, means that anyone can do it, and sometimes they're not really necessarily experts. So that's the next step, is to think about like how can you perhaps help, suggest, or even stop people from doing some of those things. But it's just the future. That's what I'm thinking.
Donc la question était, on peut faciliter avec ce type d'outils la création de visualisations qui ne sont pas forcément très bien en termes de design, parce qu'elle donnait l'exemple des barres qui ne sont pas faciles à comparer parce que c'est fait à la main, ce n'est pas très précis. Donc en effet, c'est un des problèmes. Donc si on ouvre la porte à la créativité et à toute la freedom, liberté de faire tout ce qu'on veut, en fait c'est ça, c'est cette espèce de balance entre ouvrir la porte à fais ce que tu veux et puis vois ce que ça donne, et puis probablement tu vas faire des erreurs, et puis les visualisations où on va guider peut-être plus sur les bonnes pratiques. Attention, tu viens de faire quelque chose qui est peut-être pas très bon pour les tâches, etc. Mais donc ça ouvre, c'est une autre question complètement.
OK. Merci beaucoup. On va d'abord passer déjà à notre prochain conférencier. Merci beaucoup, Nathalie. Merci beaucoup. Matthew Conlon from University of Washington, like Jessica, we had earlier. And his first job in data visualization was to design a bracket about March Madness for 538. Some of you may know the American media, 538. And his last job is hopefully as fun as the first one. Very good. Thank you, Matthew.
Thank you. All right, so I'm Matthew Conlon. I'm a PhD student at the University of Washington. This talk is called Towards Design Principles for Visual Analytics in Operations Contexts. Just want to start off by kind of unpacking that a little bit. So design principles, I think, are important for kind of providing guidance for designers about kind of when you're building a dashboard or a visual analytics system, not what you should do exactly, but these are the things that you really should be thinking about and considering. And here's kind of like, we've seen lots of systems do this before, and so you're probably going to want to take these things into consideration. And design principles like this exist and have existed for a long time, but not for particular domains. And so in this talk, I'm kind of talking about the domain of operations. And what I mean when I say operations is things like if there's kind of an emergency or some sort of crisis happening, where do you send the resources? Where do you send your people? If you're the Coast Guard, where do you put your boats? If you're designing a factory, how do you lay out the assembly line? Where do you put the workers and things like this? And the last one is spacecraft systems operations. So if you're NASA and you have to tell a satellite where to go or tell a rover where to go, how do you do this effectively? And the thing that kind of all of these have in common is that as an analyst working in these contexts, you're going to have to make a decision. You're going to have to make a decision quickly, and you're going to have to take kind of multiple scenarios into account. So there's kind of risks associated with these things because you're not really totally sure what the outcome is going to be, but you kind of want to consider this level of uncertainty across these different things. And so these principles that I'm going to be talking about are kind of motivated by work that I did over the summer, this previous summer with NASA Jet Propulsion Laboratory. So we designed a system for telecommunications engineers who are working with the Opportunity rover, which is a rover that's currently on Mars. And basically the problem that we had to solve was, can you help us optimize how much data we send back from the rover to Earth? And this thing has been on Mars for a long time, over 10 years now. And it has recently suffered hard drive failure. And so every night it has to go down for a nap and kind of power off. But the problem is that when it does this, it loses all of its data because of this failure. So anything that we don't send back is just lost, and it's kind of science that it's just in the void, and we could have collected it, but we didn't. And so this task of optimizing how much data we can actually transfer back became really important recently because of this. There's actually quite a number of variables that go into play in this situation for kind of how do you drive the rover in such a way that you maximize the data that can be sent back. There's a handful of satellites that are in orbit around Mars. And so as an analyst, as a telecommunications analyst, you have to choose one of these to say, okay, today I'm going to use this satellite, I'm going to beam the data to this one, and then that's going to relay it back to Earth. All these satellites have different orbital geometries. So kind of the path that they take through the sky is going to affect how much data can be transferred, because it could be kind of a shallow path, it could be kind of very straight up and down. And kind of the amount of time that you can sort of have visibility between the rover and the satellite affects how much data can be transferred, which kind of is somewhat intuitive, I think. There's other things that go into play, such as the surrounding terrain. So if there's a mountain blocking your view, you can't send data during that sort of period of the overpass of the satellite. the rover has a lot of the rover has a lot of instruments on it, and these instruments can also include kind of the path between the antenna and the satellite, which will cause it to not be able to send as much data. And finally, there's kind of the shape of the terrain that the thing is sitting on. So if it's on a hill, it's going to be pointed kind of off to the side, and the antenna is not going to be pointing straight up, and so this is also going to affect how much data we can actually collect. Right, and so what the analyst actually has to sort of decide at the end of the day, every single day, they have to say, okay, here's where we're going to park, here's kind of the direction that we're going to park it in, and here's which satellite we're going to use. And the reason that we're talking about direction is kind of that corresponds to, like, if we're on a hill, we know how that affects where the antenna points. And so we kind of incorporated this idea of a top-down view of the rover that corresponds to a direction a lot in our system. And so in the system, you see these polar plots coming up quite a bit. And the polar plots, they kind of correspond to, okay, there's some data straight up. This corresponds to if the rover's pointed straight ahead, it's sort of 0 degrees. There's some data on a slice over here, and this is corresponding to, you know, the rover having been turned. And at each of these positions along the polar plot, we're displaying 3 values. We're displaying this background color, this kind of blue that you're seeing, and that represents how likely is it that we can actually make a connection to the satellite. So this is an independent variable from how much data can we transfer. So first of all, we have to make sure, okay, we can actually connect. And then the 2 lines that you're seeing, the kind of red and purple lines, correspond to 2 different estimates of the same value, which is how much data we think we can transfer. Yeah.
Darker blue is better, or?
Yes, darker blue is better. So darker blue is, we're confident that we can make a connection there. And then with the 2 lines, the purple and the red lines, we want it to be out to the edge of the circle, because that means we expect to have a lot of data. And we want those 2 lines to be close, because that means our 2 models, they sort of agree, and we're doing two different ways of calculating this value. Yeah.
What's the antenna type of the rover?
I think it's a UHF antenna, but I'm actually not a telecommunications expert, but it's UHF, and it's directional. And okay, so this is kind of getting into the actual system that we built. So this is the screen that you see when, as an analyst, you log on to the thing. You enter in information about, okay, it's today, and this is sort of the position on Mars that we're concerned with, and then you get these query results back. So each of these cards is corresponding to one particular satellite passing overhead at a particular time. This information in the upper left is showing which satellite it actually is, kind of what time of day the satellite is passing at. The information in the bottom left is showing kind of, okay, we see it in the east or we see it in the west. And there's some buttons which allow you to kind of change the display of the polar plot, so you can change it between polar coordinates and rectangular coordinates if you're more comfortable with that, for example. And then the polar plots basically just explain what you're seeing there. Those differ. Yes?
Why wouldn't you just put them in GSM coordinates? That's the most natural coordinate system.
Right. So there's basically there's like a lot of legacy to this that I'm kind of skipping over. The thing has been up there for like 13 years, and so there's all these things that we have to work within because of the way that the models of the data transfer works. We have a lot of constraints around that.
But that would be the ultimate goal.
Oh yeah, I mean given like all the data that we could want in the world, there's other ways to do this, but yeah, given these constraints, this is what we came up with. Okay, so then at the top here, you have kind of some controls. You can sort of filter, toggle on and off the predictors if you want to see some more information about that. You can sort of change the size of the charts themselves and change your orientation. And then there's this selection, or there's this interaction that you have as an analyst. You can say, okay, I know that I'm interested in one particular heading. And you can sort of click and drag with your mouse to select data points at a particular heading. And then this list on the right populates. And so each of these rows on the right are corresponding to basically one slice of one of these pies that you're seeing. So the numbers on the right are corresponding to which satellite it is, and then these data points in the middle are corresponding to your purple and red estimates. And then there's some more controls at the top that kind of show they allow you to sort the list by varying things. They allow you to sort of save particular points for future investigation and send it along. And so the system was developed over a period of 10 weeks. We did field user research with 4 spacecraft operations engineers, which as researchers is kind of not very many people to work with, but there's only actually 4 people who do this job total. Basically, we derived this set of principles, sort of going through all these prototypes that we built, and sort of coming up with sort of things that you should be thinking about, or we thought, also looking at other systems that were kind of in a similar space. And I'm going to kind of skip ahead here. But basically, there's this list of 7 principles that we think kind of are important if you're thinking about these things. This is a link to the paper. It's open access, so you can download it and you can see, kind of dive in more to the work specifically. This is me, and my two co-authors are in the back here who helped design this and did a ton of great work in terms of design. So with that, I wanted to say thank you.
On a des questions pour on a des gens ici qui ont fait des tableaux de bord des fois et qui ont aussi été contraints par les habitudes et les conventions de oui,
I'm curious, was there how can someone make a call of investing 10 weeks in designing a dashboard versus 10 weeks in trying to automate the solution to this problem? Like, are there some guidelines around that? Because it's like, is that not a tough call to make in this case? Or?
Yeah, so there are so many different considerations that go into this, and the people who are using this system, like there's only 4 of them in the world who are like qualified to make these decisions because they have years and years and years of training. So this is not something that we even like really considered trying to do an AI system. Like some of our early ideas were like, oh, like we know what the highest estimates are, right? We know what sort of like maximum likelihood to optimize the total expected value transferred, but because there's all sorts of other considerations that aren't totally reflected in those numbers, we need a human loop.
Yes. How do you assess the benefit of each of these particular sectors? I don't know what you're measuring. Are you measuring magnetic field? Are you measuring thermal properties?
So that is like megabytes of data.
Megabytes of data?
Yeah.
So it has to do with the communicability. There's nothing to do with the favorable directionality of the sector.
It's the direction of the rover, yeah.
Okay. Very good. Thank you, Matthew. We literally have an astronaut tattoo here. Did you get it from them? This is how you got the job, right?
Yes.
The tattoo. Thank you so much, Matthew. We're going to move on to the next one. Thank you. Ironiquement, Benjamin Bart ici étudie et travaille à l'université d'Edinburgh en Écosse, et donc il est gentiment accepté. En fait, est-ce que tu es français ou allemand? Non. Ni français ni allemand? Oui, allemand. Allemand, oui. Donc, je vais parler en allemand, bien sûr. Et en italien, ah oui. On vote. Et donc, Benjamin, aujourd'hui, son premier emploi, c'était comme pigiste. Il a fait une visualisation de réseau pour un client de télécom en Allemagne. Et c'était quand même ambitieux pour ceux qui ont essayé de faire de la visualisation de réseau. Quand même, comment ça c'est pas n'importe quoi. Et son dernier emploi en visualisation de données, il espère, sera en visualisation de données.
Merci pour l'intro. Bonsoir. Ouais, c'est vraiment bizarre que moi, c'est le seul qui fait la présentation en français, mais bon. Si quelqu'un veut faire la traduction simultanément, on va voir. Ok, alors, je suis à Édimbourg et je présente le Design Patterns for Data Comics. Je n'ai pas traduit ça, je ne sais pas traduire, si quelqu'un m'aide. Et ça, c'est un travail qu'on a fait avec Sejong Wang, Matteo Farinella qui lit, Dave Marirast et Nathalie Henrich là-bas. Alors, les data comics, qu'est-ce que c'est les data comics? Est-ce que quelqu'un l'a déjà vu quelque chose comme ça? Ouais, ok. Deux, trois. Vous me donnez d'autres exemples. Donc, les data comics, c'est un format assez nouveau, on pense. Ça fait quelques années qu'on a commencé à explorer ce nouveau médium. Et ici, c'est un exemple des data comics, un data comic qui montre le changement des alliances en Europe avant la Première Guerre mondiale. Donc, ce qu'on avait fait, vous imaginez, si vous connaissez l'histoire, c'est un peu un bordel. Ça se dit en français comme ça.
C'est compliqué.
Et c'est compliqué. Alors, ce qu'on avait fait, on a utilisé le langage des comics pour réduire cette complexité. On a des panels, des petits panels qui focalisent le reader à un message par panel. Et on a les images et le texte qui sont complémentaires, donc on peut montrer dans les images d'autres choses qu'on peut dire dans le texte qu'on ne peut pas montrer dans l'image. Et dans ce cas-là, on utilise un langage visuel assez simple. Puis après, on a bien sûr la séquence dans les comics, et comme c'est un médium assez classique pour le storytelling, on pense que tout le monde, enfin beaucoup, sont habitués à le lire. Donc on commence à lire ici, et puis on regarde l'histoire, comment le déroulement de ces événements à l'époque. Et puis, les comics, c'est un autre avantage, à notre avis, c'est que ça donne un overview. Donc, moi, comme reader, comme lecteur, je peux regarder cette image pendant des minutes. Si je n'ai pas compris, je relis le texte. C'est à mon propre pace que je peux lire et perceptionner l'histoire. Et puis, après, il y a le overview. Donc, si je ne me souviens pas, qu'est-ce qui s'est passé à cette époque? Je regarde, oui, c'était le début de la guerre, c'était ici, là-bas. Et je peux vite fait aller là-bas. Dans une vidéo, il fallait utiliser le slider, aller avant, et c'est un peu la galère. Donc ça, en gros, c'est les data comics. C'est un format qu'on pense qui a assez un impact et qui facilite le storytelling à travers des visualisations. Donc, on a un article qui discute cette médium un peu plus en détail. C'était un article en comic, accepté par une revue informatique en 2017. Ça s'appelle The Emerging Genre of Data Comics. Donc, si vous regardez Google, comme François a suggéré, vous le trouvez. Et donc après, on s'est posé la question, qu'est-ce qu'on peut faire d'autre avec ces genres de data comics? Est-ce que c'est que pour les graphes, ou est-ce que ça peut marcher avec d'autres visualisations? Et pendant l'été, nous, les collaborateurs, on a fait beaucoup de data comics pour a large range of data. Par exemple, on a fait pour la Personal Data Visualization, ça c'est un exemple qui montre le sleeping patterns. Donc le mec, quand il est allé au lit, quand il s'est réveillé le matin, et la hauteur des barres, ça montre quand est-ce qu'il y avait quand il a dormi. Donc, et l'autre exemple, c'est un exemple pour le CO2 consumption ou production. Pour moi, c'était mes vols dans un an, et le CO2 que ça produit, 21 tonnes, 23 tonnes, c'est assez. Et puis dans le comics, dans cet exemple, on explique qu'est-ce que ça veut dire 23 tonnes. C'est un peu ce qu'avait dit Jessica dans son talk, ce genre de comparaison. Après, pour vous, si vous connaissez le talk de Hans Rosling, le TED Talk sur le Global Health, on a pris cette vidéo, on l'a transformée dans un comic, les premières minutes, parce qu'on voulait savoir comment ça marche avec des comics, facilement, c'est facile. Puis Matteo, il a pris une expérience d'un article Neuroscience qui montre une expérience avec un souris. Il a transformé ça en comic, et Matteo, il est assez professionnel, vous voyez. Donc, si vous voulez voir plus des comics, il y a le website datacomics.net. Et donc, pour les autres gens qui connaissent d'autres data comics, envoyez-nous les data comics, comme ça on peut les mettre sur le website et les partager avec tout le monde en fait. Alors, à ce moment-là, on se disait, ok, nous, ça a pris beaucoup de temps de le faire. Comment est-ce qu'on peut aider aux autres de créer des data comics? Où est-ce qu'on va commencer? Comment est-ce qu'on peut lower the bar pour les autres de commencer les data comics? Et alors, on s'est décidé de faire des design patterns. Design patterns, c'est un concept qui vient de l'architecture. Par exemple, dans l'architecture, on a des portes, des fenêtres, des terrasses, tout ça. Et c'est un objet qui revient. C'est un pattern qu'on peut utiliser pour une solution spécifique. Ici dans l'architecture, mais ça peut s'utiliser dans la computer science et dans le design en général. Alors, nous, en design patterns pour le data comic, qu'est-ce que c'est? On se disait que voilà, ça c'est un ensemble de panels avec un layout visuel et avec une relation dans le contenu. Donc, il y a une certaine relation narrative ou temporelle entre les panels. Et c'est des petits composants réutilisables. Alors ici, ça c'est un exemple qu'on appelle Zoom. C'est super facile en fait. C'est un layout linéaire. Je commence à lire ici. Je vois l'Afrique. Je fais un zoom in dans Uganda et puis un autre zoom in. Et la relation du contenu, c'est en fait la granularité. Donc on va faire un zoom. Et il y a des pendants dans le vidéo. C'est un zoom animé par exemple. C'est un autre design pattern qu'on a trouvé, le temporal sequence. C'est facile à lire. Également, c'est une séquence linéaire qui montre le déroulement de temps, le changement pendant le temps de cette ville-là. Une autre pattern aussi linéaire dans ce cas, qui on appelle multiple explanations. Ça veut dire que c'est la même visu, presque, mais dans chaque panel, on montre un aspect divers. Et à ce moment-là, je peux jouer avec le layout. Dans cet exemple-là, c'est très linéaire. Je commence à ça, puis ça, et puis ça. Mais si je change le layout et un peu la taille, ça s'écasse, en fait, la linéarité, et ça devient plus exploratif. Maintenant, je peux commencer à lire là, ou peut-être ça c'est grand, donc peut-être c'est plus important que les autres. Donc il n'y a plus de linéarité dans ce moment. Et donc, ici, un autre pattern qu'on appelle le large picture. On a une grande visualisation là, c'est de l'exemple de Hans Rosling. Et puis, il y a des petites panels, ça se voit un peu mal sur l'écran là. Il y a des petites panels là, qui, chaque panel montre un détail de cette grande picture. Donc, ça c'est un pays, c'est la Chine, donc cette panel-là parle de la Chine. Ce panel-là parle des États africains. Donc ici aussi, on peut la structure linéaire au début, et puis je peux choisir quel panel je veux lire, quelle partie de la visualisation je veux comprendre mieux. Et un dernier pattern que je veux présenter maintenant, c'est le flashback. On l'appelle flashback. Parce que ici, je commence à lire là, je lis la visu, je lis ça, et là, c'est le mec qui demande « Oh, what's about this ?» So, pourquoi il y a ce truc dans la visu qui est un peu outlier. Et donc, on rentre dans un boucle après. Donc, ça c'est un truc qui est un peu unique dans les comics, je pense. Et alors, comment est-ce qu'on peut expliquer alors le layout? Parce que je parlais beaucoup de pattern qui est un layout et une relation de continu. Donc, le layout, on a organisé le pattern dans une dimension qui commence avec non-linear layout. C'est ce que je disais, le big picture, et chacun peut regarder ce qu'il veut. Et puis, l'autre partie de la de spectre, c'est le layout linéaire. Alors, pour les relations, juste quelques secondes. Je commençais plus tard. On a des catégories, des patterns. Il y a des patterns narratifs qui expliquent des choses autour du data. Ce n'est pas que la data. C'est par exemple quelles sont les figures, les personnes, les places, les patterns temporels qui montrent le déroulement des temps. Il y a pas mal. Ça, c'est juste un exemple. On a 29 patterns. Le faceting, c'est des facettes multiples. Le visual encoding qui explique comment lire la visualisation, quels sont les axes et qu'est-ce qui se passe dans la visu. Des granular patterns qui montrent en détail. Et puis des spatial patterns. Par exemple, si on a une carte grande, comment est-ce qu'on peut regarder un détail qui est assez caché dans la visu. Puis on a fait un workshop pour voir si les gens sont capables d'utiliser les patterns pour créer des comics. Les comics, c'était dans le... Il y a des petites cartes qu'on peut utiliser. Et après, les étudiants, pendant 2 heures, ils ont fait des comics avec les cartes. Puis à la fin, on est assez contente avec ce qu'ils ont fait. On a regardé un peu quelles étaient les difficultés. Mais je veux finir avec qu'on pense que les data comics et les design patterns pour les data comics, c'est un moyen assez facile pour enseigner les deux choses à la même fois, la visualisation et le storytelling, et peut-être aussi le data literacy, visualization literacy, data literacy, tout ça, dans un truc assez facile. Et ça ne coûte rien d'imprimer les cartes. Donc, si vous êtes intéressé, vous allez chez, ça c'est un des exemples, chez datacomics.net. Il y a pas mal de comics, il y a aussi le matériel pour le workshop, donc il y a les cartes, les patterns et un peu la méthodologie. Et c'est ça. Merci.
Merci beaucoup, Benjamin. Est-ce qu'il y en a qui ont des questions? You can ask in English. You can also ask in English, Italian, and German, apparently. And another one undisclosed yet. Arabic, I guess. Spanish, okay. Mandarin. So no question, or it was very clear, and you have the link there anyway, if you're interested to know more, as I am. So thank you very much. Now we have Leo Liu from Adobe Research. His first job was to develop these visualizations as a undergrad research assistant. In what university?
National University of Singapore.
National University of Singapore. In which country is that? And well, not unlike I think a couple of our speakers now, he hopes that his last job is going to be in data visualization. So that's what we do, and doing more on data analytics and human data interaction. So Leo.
Thank you. Hi, so I'm Leo from Adobe Research. I'll be presenting Data Illustrator, which is in collaboration with my intern, John Thompson from Georgia Tech, and also my collaborators from Adobe and Georgia Tech. So data visualization is a very popular medium for storytelling and communication. As we have seen, there are many applications in data journalism, personal informatics, and also data art. So when it comes to the design and production of these visualizations, the designers have many tools at their disposal, but each has its own limitations. Business tools such as Tableau and Excel, they allow quick generation of charts, and they're relatively easy to learn and use. But the charts are hard to customize. And then we have programming toolkits like D3 and processing, which is really powerful and expressive, but it takes time to learn. And also for many designers, programming is simply too hard. And finally, designers use tools such as Adobe Illustrator in their daily jobs, but these tools don't really have good data encoding support, which makes the authoring process tedious and error-prone. But if you have enough time and patience, you can still create amazing designs. To address these limitations, we present Data Illustrator, which is a novel authoring tool which is based on existing design tools with automatic data encoding support. No programming is needed. So when we designed Data Illustrator, we try to achieve power and expressivity similar to programming toolkits with improved learnability and usability. So to give a glimpse of how Data Illustrator works, I'm going to give a quick demo by creating this particular triangle chart designed by Column 5 Media. On the left, we have the data. This data set is about the chances of getting funding for different types of resources, like books, supplies, and technologies in different subject areas. And And on the right, we have the visualization. Each triangle is colored by the type of resource. And then the height of the triangle represents the chance of getting funding for that resource in that particular subject area. So for example, you can see it is much easier to get funding for all the resource types in math and science compared to special needs, for example. So now we're inside Data Illustrator. We start by using the pen tool to create, to draw a triangle. And then with the triangle, we can repeat it by data. So we can first repeat it by the type of resource. There are 4 types of resources in this data set. So we can just use the grid handle to review all the copies and then change the distance between them interactively. Next, we take this collection and repeat it again by subject area so that we generate all the copies we need for all the data rows. And next, we can do some data bindings. We select the top anchor point, and then we bind its Y position to the chance of getting funding. And then we interactively change the axis, so 0 aligns with the bottom of the triangles. And then we can apply more data binding by map the field color to the type of resources, which generates this color legend, which later we can customize. We can do additional touch-ups by, for example, changing the width of the stroke width to 0 for the triangles, and then also changing the opacity. And finally, all these legends are interactive, so you can just go there and change the colors that you want mapped to each type of resources interactively. All right, so so this is a quick demo. So Data Illustrator is not really the first tool people have tried to design to support visualization creation without programming. For example, Lyra and IVIS Designer, they adopt a template-based or a grammar-based approach for visualization authoring. And Brad Victor's drawing tools and data-driven guides, and also Data Inc., which was just presented by Natalie and Fanny, also share many similar ideas with our approach. We call this approach lazy data binding. The main idea is that you sketch or draw things first on the canvas, and then you apply data binding whenever it's needed. The main focus of our research is really on expressivity. How do we take the lazy data binding approach and scale it to describe a wide variety of visualizations? In other words, we want to identify a set of building blocks that can describe the structure and generation of diverse visualizations. Now, to answer this question, we held weekly meetings with 3 designers over 2 years. And then in the meetings, we ask the designers to create some visualizations we have sampled from different sources using the tools of their choice, so that we can get a better understanding of how they think about visualization creation and also the tools they're using. And based on their demos and feedback, we created about 40 storyboards and mockups, which would illustrate how an authoring tool would work. So when we were trying to find the building blocks, we followed 3 principles. The first one is that whenever we come up with an idea that's borrowed from an existing design tools, it must be consistent with how it is used in the current design applications. And secondly, these building blocks should be interpretable by designers so that they can understand how they work. And finally, these building blocks should be composable so that designers can piece them together in different ways and come up with novel designs. Right, so here is a quick summary of the main concepts in our framework. We have 4 high-level categories: graphical primitives, generative operators, structural descriptors, and data binding concepts. I will explain them in more detail and also demonstrate how they work in the interface. So like all the design drawing tools, all the shapes inside Data Illustrator are composed of anchor points joined by line or curve segments. And then we have 2 generative operators here. The first one is called repeat. So here we are looking at a sample data set. It's 2012 Olympic medals by country and also by medal type. So we can repeat a circle, for example, by any categorical data variable. So we can repeat, for example, by the country, so that we generate 1 circle for each country in the data set. All the rows that share the same value for the country variable are attached to each circle as its data scope. And we refer to the generated circles as a collection. Similarly, partition divides up a shape and then attach data to the generated shapes. So here we can divide up a rectangle and partition a rectangle by country. And similarly, we get all the rows sharing the same country value as each rectangle's data scope. And then we have a collection of rectangles. So with repeat and partition, we get collections of shapes which can be arranged in different layouts. For example, a grid layout, a stack layout, a radial, or a packing layout. So in our current implementation, we are supporting the first two, but we're planning to add support for the other layout as well. Collections can also be nested. So for example, I can first repeat a rectangle by country, and then I can partition each rectangle by metal type. So this quickly gives us a structure which will be ideal for a stacked bar chart. Similarly, as you have seen in the demo, we can repeat a triangle by a type of resource, and then we can repeat the entire collection again by a different variable to create this complex structure. And all the shapes generated by repeat or partition appears to each other. So if you manipulate any one of them, the changes are propagated to all the other shapes. So this applies to the size as well as the color. And lazy binding is achieved by selecting a shape on the canvas and then selecting the variable from the drop-down menu on the right. Data Illustrator automatically creates the data encodings. So here we're binding data to the color and also the size of the shapes. And finally, all the scales and axes are interactive, so you can customize the data mapping and also the range in the numerical scale. So here is a list of all the different kinds of data visualizations we can create using Data Illustrator. All these examples are available online in our online gallery. You can open them inside the app, play with them, and also watch the demo video to see the workflows. So designers have also started using Data Illustrator to create things we haven't really thought about. So this particular designer from the Netherlands, he created a variant of the lollipop chart showing on the right. So he tweeted about this tool and said, usually it would take him several hours to do this design in Illustrator, but using Data Illustrator, it will just take him a few minutes. So as future work, we plan to add support for polar coordinates and also radial layout, and also add support for hierarchical network and geographic data. And also, designers have requested that it will be really nice if all these visualizations can be reused as templates, so that they don't have to start from scratch. And finally, adding support for animation and interaction is also something we're thinking about. Right? So, so here's the URL of the system. We encourage you to try it. And tomorrow at Kai, we're giving a longer talk about this project with longer and also more interesting demos. Thank you.
Very well done without the note and the black branding here. Do we have questions for Leo? Yes, we have one in the back there.
Just curious, so when you want to like add new data, for example, so you kind of had to create each individual mark that's directly bound to a point of your data. So if you want to load like a new data set, would you have to then re-edit the initial file as well?
Do you mean importing a data set on an existing design? Yeah, that is not supported right now. We're working on that.
Cool.
Yeah.
Oh, I have a question. If you want, you work at Adobe, do you want to tell us about the commercial future of that tool?
Yeah, definitely. I think it's our hope that this will become a real product. But it's not totally clear whether this will be a standalone app or whether this will be some features added to Adobe's existing products. We're exploring both options right now.
And I think one last question too.
Well, I saw a demo that came out, I think over the summer for Project Lincoln.
Yes.
What's the relationship? Was that based on this, or this based on that, or independent teams? Or?
Yeah, and so these two projects are related. So Lincoln was led by Bernard, who's one of the co-authors on the paper too. So we have collaborated a lot.
Very good. So we are going to go up. We are still on schedule, or 5 minutes behind. Thank you so much, Leo. That was super interesting. And yes. And now our next talk is going to be by Alice T. And our first job was a PhD in computational media design. Good first job. It's a good way to start with a PhD. And she hopes that her last job is going to be about making data more accessible to the general public. So she's well on her way. It's interesting because we already had like 2 or 3 mentions, I think, of the data today. And again, I think we're going to talk about it as you all fascinated by the Chris, we're with you. Go.
Okay, hi. Thanks for the introduction. I'm Alice Toot, and today I will talk about a study we did on self-reflection and physicalization construction. So we're getting analog, I guess. And this is work I did together with Uta Hinrichs, Samuel Huron, and Sheila Carpenter. So physical visualizations, or physicalizations for short, have been used for personal reflection actually for millennia. So early examples that you can see here include lunar markings on prehistoric bones and tallies of personal accomplishments. And some people still use this practice or similar things today. So for example, the Lego visualization there over on the right by Michael Hunger, he used that to track work hours on different projects. In 2014, we devised constructive visualization as a paradigm for creating visualizations by assembling simple tokens that represent data, so similar to the ones you can see here. And in this study that I'm talking about today, we wanted to understand how people use this approach to create personal visualizations. And we were also interested in how this process facilitates reflection. So in our study, we had 9 participants who were all not experts in visualizations. And we provided these participants with a kit of different physical materials. Over there you can see them. And during the studies, these participants used these materials to construct visualizations about a topic of their own choosing at home for 2 to 4 weeks. To familiarize participants with this process, we ran a group workshop where they could try the activity first. And after this, we asked them to develop a plan of what they were interested in exploring. And then we talked to them about this in pre-interviews. And then they constructed their visualizations at home over the course of 2 to 4 weeks, as I said. And they captured also their process and reflections in diaries. And last, we ran interviews in people's homes where we covered their process and what they found through this activity. So to get right to the results, here you can see an overview of all the physicalizations that our participants created. And this already shows kind of that the process allowed them to create quite diverse representations and also to explore very different topics. And the visualizations also show quite a few different form factors. So you can have some wearable, decorative, or embedded visualizations here. In our analysis, we were interested also to understand how did people make these. And so all participants started their process with a design phase where they basically decided which data attributes about their topic to log and how to map this data to the characteristics of the materials. And after this, participants started to continually construct their data. So whenever a relevant experience occurred, they went through a series of steps. Some started the process by logging their data separately from the visualization, so digitally or on paper, and the others directly manifested their experiences physically. So this happened by preparing tokens, for example, by counting or arranging them, and then integrated them into the physicalization. And this process is kind of interesting because only 3 participants logged their data separately. So all the others didn't really have a data set, but instead made their experiences physical right away. And this differs from how we usually think about visualization processes. And also, when we think of self-tracking, usually data entry is treated separately from visual overviews that the app would provide. Participants also reported quite diverse reflections from this activity, and this included insights directly derived from the data, for example, trends or correlations, interpretations of the data in the light of their personal context, reflections on their actions, which allowed participants to develop motivation and actionable strategies, and also contemplations of their character, values, and attitudes. And in particular, the last 2 types included quite deep self-reflection. So I will give you some examples of these 2 in particular. So participant 5, who was visualizing data about her level of focus during writing, for example, stated, I changed my writing process a lot thanks to this visualization. I realized that working in longer sessions was more beneficial for my writing process. I could have these longer threads with no beats, which was representing times where she was not distracted. And as I said, participants also often related findings from the visualizations to their own value system. And for instance, participant 6 here explored enjoyment of different activities. And in the interview, she showed me small red beads in the visualizations and explained to me that these stood for times with her friends that she didn't enjoy. She reflected on this and said, but it's good that I did it because we haven't talked in so long, so it's good that I spent that time cultivating the relationship. Or participant 5 explained how the physicalization activity changed her attitude towards her ways of working. So she said, be a little bit more compassionate about your writing, but not too much. Finding that balance was a good discovery and not feeling guilty. You should not be so strict in evaluating what's success. So it is also interesting to note that these self-reflections that participants reported were deeply intertwined with all steps of physical construction. So they basically happened while people were making the visualizations rather than passively sort of looking at them after. We further analyzed what aspects of the physicalization construction participants experienced as beneficial, but also as challenging for reflection. First, we found that the personal involvement in both the design and construction seems to support the internalization of gained insights. So for example, participant 4 stated, on digital apps, I really rely on the app's analysis versus my own. Whereas in this physicalization, I felt like I was starting to have an intuitive understanding because I built it myself. The physicality of this process made it enjoyable for participants, but they also found that qualitative aspects of their experiences were easier to represent directly. So for instance, participant 7, who visualized his meditation quality, explains how his process worked. So he says, I take one piece of plasticine, start to roll a ball, and then you can look at the ball and be like, does this feel right? And then add and subtract more. So this really shows how participants directly visualize their experiences without separate data logging. But the physicality also posed some challenges, such as the physical constraints sometimes getting in the way of accurate representation. So this is kind of a challenge. Manual effort also helped internalizing the understanding gained from the data, and also the slow process that this technique prefers created opportunities for reflection and also a sense of attachment to the visualization. So for example, participant 6 said, Digital logging is practical just to see what happened, but with this you invest so much time and energy thinking about it, so it has more value. However, while the created representations can theoretically be interactively explored by moving the tokens around, our participants found that this was too much effort, and only one participant actually used the tokens in an exploratory way. The presence of the objects in everyday life supported serendipitous encounters, reflections, and social interactions. So for example, participant 3, who visualized her mood, said, "I think for my husband it was also fun to follow it. We could just talk about it without actually thinking about talking about it. It's just something that happened because it was there." So from our analysis, we proposed several considerations for the design of both digital and physical visualization tools for self-reflection. First, we proposed to explore visualizations as a means for direct data input. And this means, for instance, you could sketch new data points into a representation or manipulate aspects of the visual marks in order to input data. And another interesting avenue for future research is using visualizations as generative tools, for example, to plan future activities, which one of our participants did. In our study, we provided guidance to participants in form of our introductory workshop, but in the future, it would be interesting to explore ways to integrate instructions into standalone personal data construction kits or apps. Last, the large variety of materials we provided in the kit gave participants expressive freedom, but also caused problems in the readability of some of the physicalizations. So it would be interesting to explore if there's a sweet spot between expressive freedom and meaningful constraints. And with this, I will conclude my presentation. Thank you for coming.
Est-ce qu'on a des questions pour Alice? Vous allez aller voir son paper vous aussi en ligne. Alors, merci beaucoup, Alice, pour ton temps avec nous. Ça a été vraiment intéressant. Je pense que toutes nos présentations aujourd'hui, on peut s'entendre. Hein, c'était vraiment super de les avoir avec nous. On va juste clore ça pendant 3 minutes ici avec vous. Je suis sûr que tout le monde a hâte d'aller payer sa bière de côté de la rue. On veut l'avoir gratuit ici. Première part, on en a plus besoin. Chris, si tu veux venir nous parler de Magdi, que tu connais bien, qui est notre commanditaire principal chez la Meetup. Ouais.
Bon, ben voilà, je travaille à MapD, donc je leur ai demandé est-ce que vous pouvez nous donner plein d'argent. Là, on est riche. Alors, donc, on va payer la pizza, des fois c'est la salle, des choses comme ça. Donc, un gros merci à MapD. Qu'est-ce qu'on fait chez MapD? Ben oui, c'est vrai, la visualisation. Donc, MapD, c'est un logiciel pour analyser de façon visuelle des grands ensembles de données. On a toujours besoin de gens pour nous aider, donc si vous programmez, si vous êtes designer d'outils de visualisation, c'est vraiment ce qu'on fait. Ce qui est intéressant, c'est que ça roule sur le GPU, donc c'est vraiment une technologie qui permet de visualiser de façon très interactive des grands ensembles de données. Moi, ça m'intéresse beaucoup. Je travaille ici à partir de Montréal, donc si on trouve des gens à Montréal, on pourrait se trouver un petit bureau, on pourrait se voir, puis ça permet de bénéficier de tous les avantages de la Silicon Valley. Chez vous.
Ok, super. Merci beaucoup. Ça ici, c'est où on va aller prendre un verre. Après, sur la carte, vous voyez, on est ici. Vous êtes rentré par le coin. Vous avez simplement qu'à descendre jusqu'à la rue Sainte-Catherine. Et là, vous allez voir ce bar ici qui est à 150 mètres. Donc, c'est vraiment très près. Et en continuant, j'aimerais inviter quelqu'un ici en avant. Ah, s'il y en a d'autres qui veulent être au commentaire, on a de la place encore. On a encore de la place dans notre fond de vente. C'est la bonne nouvelle. Comme je vous ai dit, vous avez des annonces. On a des annonces si vous voulez faire des annonces, on vous donne le temps. Mais il y a une personne que j'aimerais inviter en avant, et c'est Mathieu, ici, qui va venir jusqu'avec nous ici. Parce que sans Mathieu, Meetup aujourd'hui n'aurait pas eu lieu. C'est Mathieu qui nous a contactés en premier. qui nous a aidé à sélectionner les conférenciers et qui a envoyé la première invitation. So Matthew is the one that made it happen today because he thought of contacting us in the first place. And all the speakers know that the first email they got was from Matthew. This is how we lured them in. So we're going to do something special we've never done before. We're going to make you an honorary member of Visualisation. Thank you. Is there anyone else who wants to make an announcement? I think we have at least one person. Yes.
Hi, I'm Audrey from Function. So Function is looking for a front-end developer, intermediate to senior. So what do? We are an information design company. We work with big nonprofits or big companies like Google or 3M to create digital storytelling experiences and data-driven applications. We are B Corp certified. We are a small team of designers, developers, and a dog. And so if you're interested in joining us, please check out Function. I think Francis posted the ad on Twitter. So otherwise, I'll see you at Dog Fest.
Thank you. Anyone else with an announcement? Yes?
Do you want to announce the co-op-a-thon here that we're having here with VisMTL? So for those that are local residents here, we have a co-op-a-thon for 2018. It's a very big thing here. It's an international co-op-a-thon. It's happening in conjunction with Desjardins Lab. They were having the first info session tonight, but they're having the second one on the end of May. If you want to look in that, they've added another department. They've added an environmental department so that you can put your projects online with them.
So what do you look for if you Google it?
Cooperathon218.com.
Coopérathon2018.com. Super, merci. Est-ce qu'il y avait d'autres annonces avant qu'on fasse nos deux dernières? Vous savez où on va faire J'espère que vous êtes tous au courant que ce soir, en fait, c'est comme la veille de Noël. C'est pour ça qu'on s'est réunis ce soir, ou la Saint-Sylvestre, parce que demain, c'est le premier International Chart Day de 26 avril. C'est vrai, ça a été créé. Dr. Carroll est là-dedans aussi, mais je pense que c'est lancé aux États-Unis. Mais surveillez votre fil Twitter, Facebook, etc. Vous allez voir énormément d'actions autour de International Chart Day. Ça existe pour de vrai. Et la dernière chose, on peut annoncer notre prochain meet-up qui sera le 31 mai à WeWork à propos de Database and UX, l'expérience usagée et de la visualisation. On a déjà des conférenciers. Est-ce que, Santiago, on a une confirmation de tu sais qui pour la date?
Je te confirme après, mais presque.
On ne peut pas le dire encore.
Non, c'est une surprise.
On ne peut pas le dire encore, mais on a des invités internationaux encore qui vont venir nous parler de Database and UX. And this is it. You're free to come with us. Actually, those who want to go for the drinks, Jessica in the corner there with the hands is going to leave right now with the first bunch. And as we finish cleaning the room, we're going to leave with whoever is here. Thank you for coming.